Isolated tornadoes, damaging winds, large hail, and flash flooding in multiple states. Good morning, I'm meteorologist Pew. Today is July 18, 2025. Today we'll possibly see an isolated tornado event, especially in the Midwest. We may also see large hail from 1 to 2 inches in these same areas, but we also may see small hail from the Rockies all the way to the Midwest. And we may see damaging winds up to 60 miles per hour in the Midwest all the way to the Rockies, but also in the Mid-Atlantic, including Virginia and North Carolina. For flash flooding, the Weather Prediction Center has issued a moderate risk, or a 3 out of 4, in Virginia, and a slight risk in many other places as well. So in these places, we're going to see rainfall up to 1 to 2 inches in the next 24 hours, but in Northern Virginia specifically, some places may see 3 inches or even more. Places like the Midwest, where the severe weather is going to occur, we can see 1 to 2 inches of rain in the next 24 hours. And then from Louisiana to the Florida Panhandle, you guys are getting the remnants of that tropical disturbance that we've had earlier in this week, and you can see rainfall up to 1 to 2 inches, but especially in western Louisiana. Okay, so time frames. From Virginia to North Carolina, looks like these places are going to see something around 19Z or 3 p.m. Eastern time. From Louisiana to the Florida Panhandle, you guys are going to see pretty much rain all day, all afternoon, but it's going to diminish by the time it gets night. For the Midwest, especially from the border of South Dakota and Minnesota, it looks like things are going to start around 18Z or 1 p.m. Central time. But the stronger storms won't start appearing until around 9 p.m. Central time. And then by tonight and next morning, places like Iowa, southern Wisconsin, and northern Illinois are going to see these storms. Looking at the surface from the Mid-Atlantic to the Ohio Valley, we have a stationary front that's going to produce constant convection in these areas. We have a high pressure in the Atlantic that's going to be pulling in warm, moist air from the southeast into these areas. Looking at the Midwest and plains, there's a low pressure centered around Colorado that's bringing in warm, moist air from the south. And then we also have a high pressure in Alberta, Canada that's bringing in cold, drier air. Currently in the Midwest, we have a low pressure, and alongside that, we have a warm front and cold front. But eventually this front is going to turn into a stationary front. But as the day progresses, depending on how much cold air and hot air interaction we're going to have, is going to depend on how much surface forcing we're going to have in this area. If we take a look at satellite imagery, we can see in the Midwest, it's pretty cloudy, and that's going to prevent diurnal heating or surface heating, which is going to make this area a little bit more stable. Now, if we flip back to the Mid-Atlantic to North Carolina, we can see that we have pretty much clear skies, and that's going to be good for diurnal heating. Looking at 500 millibars or midway through the troposphere, we can see that in the Mid-Atlantic, we have pretty decent shear, which is going to be good to tilt those updrafts and prolong those storms. Looking at the Midwest, we can see that we have really good shear in places like central Minnesota, but nonetheless, these places that we are concerned about still have pretty decent shear. Something I do want to point out, if we look at 850 millibars, so low levels in the troposphere, we can see that we have a low level jet, and that's going to contribute and aid in the convection in this area because it's going to bring in moisture from the south. But another significant feature that this is going to do is that from the surface to 850 millibars, the wind direction is going to change, which means it's going to add spin to the updrafts that do form. We can see that the winds start more southerly and quickly turn into more southwesterly, and we call that winds veering with height, or winds going clockwise as it goes up with height, and that's a really good requirement for tornadic activity. And that's why we have